just want to say thank you for showing up for our presentation. It means a lot. So in case you don't know who we are, I am Lisa. I've been working with the Linaro Power Management Working Group for over 2 years, and the gentleman next to me is Vincent. He's the tech lead for our team and been around much, much longer than I have. And so Vincent and I have been working with the Linaro Lava Lab team for the past few months, trying to get a board form set up for our team inside the Linaro Cambridge lab, which the Linaro Lava Lab team is here as well, if you have any lab infrastructure questions. So we're just going to move over to the agenda slide where so our talk is just an introduction to our board form where we talk about the purpose and a setup and then the advantages, limitations. We do have some test results to show and then discussing the next steps. And then go ahead to the next slide. So ideally, it'd be nice if every developer would have reference boards on their desk that they can access to anytime, be able to run their tests locally. But that's not always the case, in this, especially when it comes to cost. So what we're trying to do is just create a farm so that we have reference boards available for everyone on our team to have access at any time and be able to run their own benchmarks or whatever they need to do on the boards directly. And then also just to automate the benchmarking process where, we want to be able to devote more time to working on other tasks and have testing running in the background. And then over time, when we collect test results, be able to graph trends and then decide what to do next based on those trends and scores.
You want me? Yeah, clearly we have these two purposes that unfortunately we weren't able to have one board with all the probe and access to each port domain for all our engineers. So we need to find a way to share that, and using this server is quite, seems to be one of the best and efficient way to do that. And that's also something that we lack on to have a good view or trend of what is the power consumption, how the power consumption evaluate on the main line, and how we can check that what we are doing is going on the right side, on the right direction.
So we're going to go into the setup, and so generally we just started out with 3 boards: a MediaTek board, a TC2, and a Panda board. And then we're still in the planning stages where we're trying to figure out, what distributions or which kernels we want to run on. So some of the ideas we came in mind is just to run on Android, Ubuntu, and then kernel-wise, just see we can try LSK and mainline. And then on the server side, it's running Debian, and then we have 2 tools installed on the server at the moment, which one is the ARM workload automation tool, where it'll help us run benchmarks repeatedly, and also the ARM probe command line tool where it'll help us collect power statistics from the ARM probes. And then equipment, ARM energy probes, and the PCBs with shunt resistor. And if you want to comment.
Yeah, so it's only the beginning. I mean, nothing is finished for now. It's just that the starting setup for us. So we have decided to use three boards among the one which are available for us. And so we expect maybe to have more board with good access to power domain and power supply. It's up to the members to provide us if they want. And for the kernel that we want to run that, it's clearly that we see an interest to use the mainline and the LSK. We also setting up a power integration tree on which what will be merged against the again the SCAD tip, or the tip more generally speaking, and which will merge all our ongoing development, including the EES stuff and so on, so that will be easier for us to validate everything. And so yeah, and regarding the equipment, so right now we are using ARM Energy Probe, mainly because that we have a lot of ARM energy probe available. It's nothing really linked to because it's good or bad. It's just that we have that with a 8 kilohertz 10 kilohertz sampling rate, which is quite good for us because we have access to a real detail. Sorry, we have access to a real detail per consumption. Yeah, we can have a good detail of all the dynamic behavior of the power consumption, which is quite important for us for the power management activity.
So we just want to list a couple of advantages to our farm, which one is that everyone will be working with a similar setup once they log into the server, and whether they want to console into a particular board. And so it also makes it easier to compare test results as well. And for me in particular, it'll help me to improve Linux support on workload automation. So I've been working with the WA maintainer for the past year just to add more benchmarks and other features to make sure that workload automation does run on Linux. Anything else you want to add?
No, nothing. No, you can continue.
Okay. And then we also want to address the address the limitations. So currently our board farm is managed by the Linaro Lava Lab team, and we do understand they have other priorities to take care of. So if we do submit a type of request, whether it's to check on the board or to make any improvements, sometimes they may get to us very quickly, and other times, we may have to wait a day or two. And then there isn't an easy way to check whether there are multiple users currently trying to access the same board at the same time, and also like every user is going to run different set of tests. So some tests may be completed in minutes, while others may take hours, for example. So this is just a quick list of some of the benchmarks. It's not final in any way. So we're just want to give everyone an idea of what we're looking into, such as RT-app and cyclic test and Hackbench. And then the more interesting part is that Vincent's going to talk more about the test results we've been collecting so far.
Yeah, maybe just one more point on that part. So yes, we have to start with a list of benchmarks. That's one we are using quite often in PMWG team, or at least for me. We are quite interesting to know which kind of benchmark are used also by member, which benchmark, which test or use case could make sense for you, because at the end, what we want is just to provide some number that can help the members to see any kind of improvement. So don't hesitate to come back to us and give us a list of benchmarks that you would like to see in our test. Yeah, so for the test result, have we described just before? So our farm tried to solve two issues. The first one is to share a board for all the team, and the other one is to get some continuous test, periodic tests around our a number of a kernel tree. And for that, we would like to have, let's say, two levels of results. So let's say a high-level view. So the goal is really to have one score. At the end, we would like to have just for each kernel and each time we run a full test cycle to get one score, and so that we can easily see a trend about if performance are improving or not, if power consumption is improving or not, or if we have a regression, just to detect that quite easily and automatically. And based on that, we also need this second level of result, which is a detailed view of what have happened during the test, just to help us to do some debug, maybe I can give you about, for the high score level, we are under the process of defining how we can create this score. That's quite I mean, that's not obvious to gather a lot of different results and make that usable. For the low-level view, what we are planning to use is mainly some power consumption trace. I'm going to give you a detail of an example of which kind of level we want, and also gathering some F-trace, something like that. So maybe just, yeah. So this is the kind of result we want for the low level. So this is just, I think it's a 10-minute arm probe recording. And we can see the goal is really to see the details. So we have sampled several power domain. And for us, the goal is to be able to get all this detail and to be able to run more deeply to see exactly what happened. So we want to sync that with some ftrace command, some kernel shock view, to really see what happened at one moment, which task is doing some, is consuming some power, or which task generates here, I don't know, a good power saving. So we really need that. Our goal is not to provide that outside. This is for our team, just to help us to improve and debug. And we just want to provide this kind of score. And another level is that based on that, it's just to get. So this is the dynamic view, and we also need to have, let's say, just the power consumption of one use case so that we can easily see what happened. So that's typically what we need from a power consumption point of view. And then for the dynamic, we have ftrace and the score of the bench. So yeah, so even for that, we are really now in the phase of defining what we want inside. So if you have any idea, don't hesitate to share that with us. So we are, yeah.
I'm interested with the test result. What are type of result you can show with us? Like, would you use some web page to show the result, or would you use some?
Yeah. At the end, what we would like to have is one web page with, let's say, several mainline kernel version and one score, which say, okay, we have this performance score, this power score, and we can see over the kernel in which direct trend we are going.
Yeah, that's good. And as to the test result, I think not only the benchmark output is definitely important, but also some of the kernel statistics like context switch times and some of CPU statistics like and some scheduler data, and also some of the like task running time is also valuable and
yeah.
is
so yeah,
to log. Yes.
That's why we have planned to use workload automation, because it's quite easy to define which kind of statistic you want to record with your test, so you can have access. So you can have access some energy probe, some ftrace, some CPU statistic, CPU frag as well. You can just define which kind of log you want to register for a task. So for each test, you gather a lot of data. And but yeah. And even more that, I mean, we have some. So we have benchmark, which typically give you a score. We have other use case like an MP3 playback where you don't have any score. The only things we want is just be sure that we have run the task in the, let's say, in a maximum time frame. So this means that the goal for us is also to add some post processing of log, just to check that we don't have missed any deadline for the streaming use case, for example.
Oh, yes, that's great. Thanks.
Yeah.
So for the high-level view, would you consider using Kernel CI to store those information and plot those information? Is it data publicly available, or is it sensitive data?
Nothing have been defined yet. Yes,
okay.
we have started to discuss about how to be connected to Kernel CI.
Okay. Yeah, definitely not for a low-level view because I guess it's
No,
more.
no.
Yeah.
Low-level view is for us.
Yeah.
High-level view, it's mainly just a number, so I
Yeah.
don't see any major issue
Yeah.
with that.
Thanks.
You're here.
For RTApp, you're using W8 to actually run RTApp workloads, or because I'm wondering how the JSON files or the configuration can be passed to run the tests.
Yeah, we are using workload automation, yes. So we will just generate a bunch of JSON files that will be saved in workload automation.
Will be possible to actually provide
Yeah.
a JSON file that I don't know, create in some way. Okay.
Yes, clearly, yes. For that, if you have any JSON file that you think it's worth to run out, just send it to us. We will add that.
So you previously mentioned some benchmarks.
Yeah.
So the idea is that you are just measuring active power while you are running whatever application? Is that what you mean? Okay.
Yeah.
And you are just measuring total power?
So our goal is that we have ARM probe, which just sampling. So we will have both total power and detail internally. But at the end, the score will be just about the link to the total power. But we will have both internally, dynamic and total power.
And have you considered, are you measuring like suspend power and different power states?
Yeah. Among the tests that we want to add, we have this pure performance use case where, we will have a power number, but we know that we'll just run everything at highest frequency with the highest compute capacity. We also want to use some more low power use case, low level use case to get some more LEDs, so to see how much we can enter some deep sea states, something like that. And for us, the main issue will be how to be sure that, let's say, the power consumption of pure performance tests will not just hide any variation in the low power use case. So that's one thing we have to think about. It's because we just want one score at the end, we need to gather everything in something that still makes sense. We just want to be sure that.
So I guess for what you're running right now, my bet is like probably you don't see huge difference in the power consumption. Like when you're running, I don't know, Hackbench versus cyclic test, if you're just measuring total power, probably you don't see that big.
Yeah, so right? we have total power per test. And then we need to, one of our next ongoing activity is to weight that so that, for example, if we take Hackbench as an example and MP3 playback. For Hackbench, we are really interested in the performance score more than the power. The power still makes sense just to be sure that we don't have any obvious error. But performance is really what we look at. For an MP3 playback, we are interested by the power consumption. But obviously, the total power consumption of MP3 playback is quite small compared to Hackbench. So we need to find a way that any variation that happen on an MP3 playback power consumption will be seen quite on the final score, more than any small variation on the Hackbench part.
Oh, okay. No, I thought that this talk was about just power consumption benchmarks, but now I understand that is about any benchmark.
Yeah, it's both,
okay.
In fact, yeah.
Okay.
It's power and PEF, because as soon as you try to improve power consumption, you can easily just decrease performance on other use case. So we need to check both.
So the high-level view, the one number goal is that one number is supposed to incorporate both power and performance for across all tests?
In fact, it will be a pair. We will one perf number and one power number, score number.
And this would be per test or just like a single number that covers all the benchmarks?
The eye level view will be for everything.
Okay. All right, thanks.
So kind of following up on Carlos's question, on the list of tests, I thought a good idea would be to add suspend a RAM, suspend a idle, just to really, not even MP3, but just no tasks running, so a complete idle load as well as suspend a idle. And then one way that you would incorporate that in the power score would essentially be the comparison of some running test power score to a suspend a idle, for example.
Yeah.
So you have basically looking for some, bottom threshold for the power number, and then the score would be ranked relative to that. And it would allow it to catch regressions and suspend as well, but also compare the other power numbers to.
Oh yeah, yeah.
If you happen to run, you get a use case running that's taking less power than suspend, you probably have something going wrong.
Oh, we need to.
Yeah.
we have found. Oh, we have found something.
You found a really good secret, yeah. And then one other question, I guess for Lisa, on the workload automation, if I remember right, there was still the requirements for the target is it still requires at least networking so you can SSH into the target and run the test. Is that still the basic requirement for workload automation?
So the latest update I know for sure is so in mainline there is a next branch where they're trying to, at least what I've been told, rebase WA on top of the devlib package and figure out, okay, how do we use the code in that branch to support the local Linux target, so you don't need to have networking.
Okay, so then it will just send commands over the UART then, or how will it actually control the target?
Well, that I don't know
Okay.
right now, at least not at the moment.
Actually, just to address some of that, we had a meeting yesterday with Lisa, and we're also considering over time using adding Lava to the top of this to help with the automation, the gathering of results, all that sort of stuff. It's not going to happen like next week, but over time it makes sense because an awful lot of what you're doing, Lava can really help with.
Yeah. So we have started. But now we are started at the low level. We're just increasing how can each issue can be solved.
We actually, I just double checked so I didn't say something wrong, but we actually do have support for the ARM Energy Probe within Lava. So we can actually say start measuring, gather the data, stop measuring. So.
Okay.
And I think workload automation doesn't really have a good way of defining power cycling for the boards either. So that's another thing where Lava actually would. You could imagine a scenario where Lava would kind of handle the basic setup of the board and power cycling, and then actually just kick off workload automation.
For workload automation, I mean, you have some way to define how to pull down and reset your. But yeah, I mean, I don't have any strong opinion.
Okay, then that's new since I looked at it last, and that's good.
Yeah, I think it just really depends, because I remember when I was trying to run workload automation on TC2, I ran into power cycling issues, and it took a while for me and the maintainer just to figure out exactly what's causing it. And there was, I think there was a timeout variable that needed to be modified so it would wait for the prompt to show up longer. So.
So, I mean, it's getting into the area where the workload automation and the Lava overlap is pretty, I mean, there's definitely an overlap there, but.
You can talk about the next steps.
Okay. So, yes, for the next step, we already speak about that a bit, but yeah, we want to add more board, so we have in mind to add a Juno board.
Yeah, hopefully in the next month or two.
Yeah. And so yeah, our goal is to increase step by step the number of board. And also, yeah, clearly the next step for us is to define the metric that we want to report and how to merge everything in one single value that still makes sense. If you have any idea, don't hesitate. I mean, we have some idea, but that might have already been done by someone. Yeah, so we have this power integration tree. There are a lot of other kernel, and we really want to do some tests as much as possible on that, running periodically for any change, any kernel version, or for our integration tree each time we are updating it. And yes, so the global trend is something we have already discussed previously. So yeah, so we are really at the beginning. We can change a lot of things right now. So don't hesitate to.
So in workload automation, how easy is it to kind of plug the power measurement device itself? Because like on Juno, you could use the internal, you could actually use the Juno registers themselves for power measurement, or you could use some external devices, or you could use energy probes or ACME boards or whatever. So I mean, how easy is it to define what the board or SoC specific kind of measurement tool is?
So maybe you should have asked workload automation developer to come. It's quite easy. I mean, for example, for my MediaTek board, I have been able to quickly done. You can create some instrument above, and then you can ask to say I want to enable this instrument for my board. So I have mainly worked with the MediaTek board with ARM probe connected on the cluster power domain. So
on Juno, you might define an instrument that actually goes and reads these
yes,
power registers.
and I think it's already available.
Ah, okay. Okay.
So yeah, I think most of the ARM dev board are up and running on workload automation.
Okay, cool.
So yeah, and for my MediaTek board, I have created a device in order to be able to power cycle that with I have some relay and so on.
Okay.
So that can be done quite easily.
What would be the difference is then that the hardware, you won't have the sampling when you're using it?
Yeah.
Yeah, I guess the difference will only be that you don't have the sampling when you're using the hardware monitors. So it's the type of results that you can look at, probably different. Yeah.
Yeah, but I mean, that's what we want. But if it's not possible, we'll have to cope with that. I mean,
Well, I guess in the end, if you want really get the sampling thing, you can actually, I don't know, have some kind of daemon or something running on board that samples, that produces the same thing.
yeah.
That reminds me of one other thing. So I remember when I played with workload automation last time, there was one config file per board, and it only always reads that. I mean, I remember basically having to say, if you have multiple boards in your lab, it was really annoying to actually you essentially have to remove the config file and put another config file in place to run that for the board, for the, yeah. Is that all?
You have -C to provide like which config you want.
Yeah.
So I have a multiple configuration files like config -tc2 config -Juno, so I can just pass a parameter to the.
Okay, so that's
Yeah.
I think so. Workload automation. Milos explained how to use workload automation in Lavada. I think that there is few experiments that have been done already to connect both.
A question about the testing metrics. Like the Geekbench, you may like to try the lots of different parameters to get the result, to do some comparison. Do you have some idea of this? Actually, I want to say the Intel test framework LKP Plus has really something on the testing scenario metrics.
I'm not sure to have catch. So what you say that sometimes it's not just a single value. We have a lot of information. That's it.
I mean the test scenario just like the Geekbench, you may like to test the couple of different parameters.
Oh yes. So yeah. So in workload automation, you have this kind of agenda for each use case or workload. Yes, it's a workload. You can just specify the parameter you want, so you can run the same workload with different parameter.
The LKP Plus use this type of like you can define the different metrics and it can do the automation for the workload. It can combine a different scenario like the different parameter on different platform.
We will choose that, you mean?
That's easier. That's kind of easier to automation, although combine. It's kind of a testing scenario matrix. It could be generated automatically.
Oh yeah. Okay. Yeah. Yes, for sure.
Thank you.
So yeah, this this is our question. So how can we make this farm useful for you?
Typical. You ask a question.
Yeah, a lot of questions I made.
I think this kind of infrastructure would be very helpful to collect the power performance data for us, especially on the developing features, and we can give you our Git tree, and you measure which commit can help and get some better or get some improvement whenever on the power on the performance. But I think I don't know if it's capable for the running time. If it's running time enough for lots of developer improvement input.
Yeah. I don't. Yeah.
So do you see this thing only working for like regression testing, like I run the same kind set of tests on different Linux versions, or is that it's actually something that can be helpful for while I'm doing modifications, so while I'm actually developing? So let's say I want to try modify something and I want to see if my, kind of.
So yeah, so that's why we want to make the board available also for our engineers, so that it can make a test on ongoing dev. So we have both the way to just check for regression, but also check for improvement linked to ongoing test.
So just more of an administrative question. So how are we going to work out sharing the farm? I mean, what sort of interface do you have in mind to maybe block out time per user? Or, I know that I'm going to need roughly 2 hours for my tests. Where can I schedule this, on
I don't have any idea so far.
Okay.
Okay.
So that's the point of Lava, really, of introducing Lava into the equation, because Lava does the scheduling for you. So you submit the test, and at some point when that board comes free, it runs the test for you.
Is there a way for me to know ahead of time, like what the expected delay is? Like
No. You just get the so you can assign a priority to the job. So you can say high, medium, or low, and
it's a multi-node, so you cannot assign anything.
Oh, it's multi-node, right? Okay. Okay, so you submit it, and you are in the queue behind the last one that was submitted, behind the last one, behind the one that's currently running. It just depends on usage as to whether you get on it immediately, or I mean, if you can look at the queue and go, oh, right, I'm way down. But
you get notifications when your workload start. You get notification when you start, when it's complete.
You get notification when it's completed.
Okay, not when it starts.
Yeah.
Is there a way to, let's say, to disable this automatic? I mean, we have clearly this automatic test, but we also need to be able to directly connect to the board to do some stuff for which we don't have any automatic
So
test.
that's a Lava hacking session.
Okay.
Yeah.
Okay, we can schedule a
You
Lava.
submit a job, it's kind of friendly because it will email you or ping you on IRC to say your image is now deployed and ready, and here's your SSH onto the board.
Okay, so that can solve. Except if by the time you go back to to sleep.
For this question, I have some not very good experience. Like I like to book a board from Lava and to load, but I cannot do the loading the image onto the board. So if my image has some problem, I have no way to keep reloading to change my kernel configuration or something and to do the image reloading by myself.
So you're saying you're deploying an image that just doesn't work?
Yeah.
Okay. Yeah. Well.
Then you have to wait 45 minutes for your next try. This kernel development cycle is booting lots of stuff that doesn't work before you finally get something that does work.
Yeah.
And that's where this kind of remote stuff is kind of falls apart.
Yeah. No, I get that.
Yeah, it was basically the same question. So basically, when you're I guess, I mean, my personal experience, when you're developing, you try something, you want to see if that something works. If it doesn't, you basically reveal the kernel and try something else. So,
yeah. So that's one of the things about the Kernel CI project, is that there's lots of stuff available, so that you're more likely to get a quicker turnaround. Yeah. Yeah. So your half a rack is going to become 5. I don't know, but we could. I think as you were going through that, yeah. I was sort of beginning to think there's sort of a kernel CI type problem here that we're trying to solve. So we should look at something like a PMWG CI type.
Yeah.
So we've got a distributed set of boards, we've got plenty of resources, and the turnaround time for anybody wanting to get on is faster.
Yeah, also, it seems like maybe we need to set the expectations for this properly. I mean, it doesn't seem like this is a replacement for having a device, on your desk where you can get the first cut of results and make sure you have something that performs reasonably well, that boots and gives you somewhere in the ballpark, and that this would be for more of a broad set of results across a number of devices for automation to know on a nightly basis how things are trending. But yeah, I mean, you're still going to want a device to hack on.
Yes, clearly that's something we want. We want to be able to have access to console to reload a kernel. So we need to find a way to book that board.
So that's great with the board on your desk, but when it's a Juno R2, which is $6,000, that's not, that doesn't scale well. Whereas we can.
Yeah.
Sure. I mean, I'm not suggesting that everyone has a Juno, but
right.
A Dragon board, something you make with your image.
So on to answer this question, kind of, and with the Kernel CI tie-in, I think what makes this useful is to be able to have a database of results for all the main lines and LSKs that have come along, so that when I do submit my job, it shows up. I can look back and say, how am I performing relative to mainline, relative to the stable tree, and all those things. And so and this is where the Kernel CI comes in, because that's essentially what we're doing. We're collecting lots of data on boot and build stuff, and this, I think the goal of this should be to kind of submit more of this data into Kernel CI on the power data, so that what makes things useful to me as a power management developer is submitting my job and saying, oh, I'm doing way better than mainline, or oh my goodness, mainline is way better than what I'm doing, and so I broke something. And so that's the historical stuff, the trending stuff over long periods of time. I think that's what makes it useful. Yeah. Okay. And it can also contribute, if it's connected to Kernel CI, it can be linked to kernel image size trending and all sorts of other types of trending. So I think that's what makes it. I mean, being a Kernel CI developer, I'm kind of biased towards getting this stuff kind of plugged into Kernel CI and kind of collecting it all together. So, but I see an obvious tie-in with just kind of extending this to. I mean, power testing is just yet another type of testing. So we should kind of put it all together.
And Kernel CI has how many different labs?
10 now.
10. So 10 different labs across the world with plenty of resources. So.
Except most of them aren't instrumented for power.
That's
still the tricky part.
That's the next bit. I think we probably need to sort of round table this at some point to see if we can hook in to actually getting power measurement into kernel CI. It sort of makes sense.
Yeah.
Because
So it's all possible when the device is enabled in the kernel instrumentation to get the power numbers. So there's a, so if you want to measure the power on a device, so the workload automation is expected to have a hardware monitors available on the device. So that's kind of instrumentation should be available on the development boards. Then only you can have a graph or whatever it is.
But there's, the point of workload automation is to make it be able to be board specific. So I might have some boards that only instrument DC input, for example, which might be fine and get graphs over booting, and actually so you can see it drop when you hit suspend and simple things. But then other boards we might actually have the ability to measure multiple power rails, and then we'll get a whole bunch more data. And so we need to be able to do all that. And I think for a lot of labs it'll be easy to instrument just the power jack input, but then there's not that many boards that allow you to measure the detail, so we need to be able to do all of it. Different levels for different boards. Yeah. And I think, like if I understand right, workload automation already allows you to do kind of board specific instruments like that. So
yeah. We still have 10 minutes. Yeah.
I guess I have one more question on how, what's the process of getting from now to figuring out how you're going to come up with this one magic number? I mean, it seems like coming up with this one magic number is actually quite interesting all by itself.
Yeah. Let's say that for the next Connect, we'll come with this one magic number.
Okay.
But yeah, I mean, we can keep you involved in this.
Yeah.
We have some idea. I mean, of using some geometric mean with weighted result base if it's more power test or performance test. But we need to make some. We need to check if result is really usable. So Lisa will be mainly involved in PMWG farm.
Okay.
And with probably one guy, Amit, from who is a new Qualcomm assignee. I will be also involved in that, but Lisa will be the main person involved in the farm.
Yeah, a couple of more patches are coming from QA also, to just help in the workload automations.
Okay.
Yeah, I mean, I meant more in the figuring out what that formula is going to look like. I mean, it seems like coming up with the formula for the single number is really important, right? Because once you set it and you start reporting numbers, changing that formula, is going to throw off everything.
Yeah.
So that seems like an important collaborative process. I was just wondering, if there's like key people that are going to be driving that, or.
Actually, if you think about it, I mean, if you get it wrong to begin with, and you do need to change it, as long as you can retrospectively go back and recalculate it, then it's probably
one main advantage is that normally internally so I don't know how long we will save the log, but we have the details, so we can change the formula. We can just recompute all the score quite easily. Yeah.
I just said what you said. Oh, okay. We had the same thought.
So yeah, clearly the next step are to look at each test and how we can get one score per test at least, and then how we can merge everything. So we'll probably do a lot of trial to see how any variation impact or not the result.
For power, you could use like a days of use kind of thing as a model. You know, like Samsung has days of use number, sort of a similar thing.
Okay. Yeah. Yeah. I have that in mind. That's right. That you have this kind of user profile saying that in a day you're doing some idle, let's say 50% of the time. You are doing some web browsing 10% of the time, and so on. That can be a way to weight the power consumption of each test. Yeah. Yeah. So if you don't have any more questions, I think it's done. Thank you very much.